When working with Node.js, we don't start everything from scratch. Instead, we often depend on code, functionality, and algorithms created by others, packaged conveniently as modules. We've already encountered some of this when we worked with the FS and OS modules, which are first-party modules. By that, I mean they're part of the core functionality that comes bundled with Node.js. However, a wealth of additional functionality comes from third-party packages. Node.js has a fantastic tool for managing these packages, NPM, the Node Package Manager. Essentially, learning Node.js involves discovering which packages cater to our needs and understanding how to use them effectively. So, in this segment, we're going to explore how to work with NPM, how to install NPM packages, and how the dependencies that arise from using these packages are handled in our Node.js projects. First, let's clear out any files we won't be using anymore. Now, NPM offers a website where we can find all the NPM packages. It's npmjs.com. I highly recommend visiting this site and exploring its vast offerings. The beauty of NPM packages lies in the fact that most of them are free and available for us to use. You can utilize the built-in search tool to discover nearly any functionality you might need, and we'll go through a few examples of this. So, how do we kick things off with NPM packages in our project? The first step is to initialize our project for NPM use, which is as simple as running the command npm init. Once we execute this command, we enter an interactive dialog where we'll be prompted for some information. It guides us through a series of questions, starting with providing a package name. You'll notice a default name in parentheses, which is drawn from the folder containing our project. We can choose to give our package a different name or stick with this default by simply hitting Enter. Next, we move on to the version. Again, there's a default value available that we can override if we'd like, but I'm sticking with the default of 1.0.0, so I'll hit Enter once more. Following that is the description. If we wish, we can add a description, but I'll leave that blank. We then have options to modify the entry point, test command, and a few other settings. But for now, I'll keep them as empty values too. Once we have answered all the questions, we receive a JSON representation of our responses. To confirm our selections, I'll type Y and hit Enter. As a result, a new file, package.json, is created. Let's take a moment to examine this file. It contains exactly what we saw in the terminal preview earlier. Of course, we can modify any value directly within this JSON file. So, if we missed something during the initialization, it's no problem. We can always make changes once we have the JSON file. Many people actually opt for the default values, and it's quite common in Node.js projects, as creating this file is almost a standard step. There's a shortcut to generate this file. So let's go ahead and remove the file we just created and create it again. This time, we won't have to respond to all those questions because we're going to use a shortcut. Instead of running npm init, we can run npm init y. When I hit Enter, the file gets created using the default values, which are similar to what we had before. Now, we have our package.json file ready, setting the stage for working with NPM packages. The best way to get familiar with using NPM packages is through example, and a great one is the validator package. You might ask, how do we discover this package? Honestly, there's no single answer to that. Much of it boils down to experience. The more we immerse ourselves in Node.js, the more useful packages we'll uncover. Once we identify a helpful package, we tend to refer back to it frequently. Let's look for the validator package now. Using the search box on npmjs.com, we can locate it among the search results. Let's select it, and here's the package page, which describes its functionality and provides basic usage examples. The validator package, for instance, is a library of string validators and sanitizers. If we scroll down a bit, we'll find documentation that includes installation instructions and usage examples. One of the advantages of NPM is the uniformity in how packages are installed. Regardless of the package, the installation procedure is nearly identical. The command is npm I, where I stands for install, followed by the package name. So for example, npm I validator. Let's try this out. When we run that command, the package installs, and a new section emerges in our package.json file, the dependencies section, which now includes our newly added validator package. Additionally, in our project, we'll see a new folder titled Node Modules. Any module we install with NPM will reside in this folder, containing everything necessary for its operation. Right now, we only see one folder within Node Modules, the one for the validator package, holding all its essential components. Now that we have the package installed, let's see how to use it. To begin, we need to require the module in our code. We start by defining a constant, naming it validator, and assigning it the value of require validator, which is the module we're going to work with. If we look at the validator webpage, we can find a straightforward usage example. For instance, if we want to validate an email, we can use validator.isEmail followed by the email we wish to check. If the email is valid, the function returns true. We'll similarly check a URL. Let's define a constant called isValidURL, assigning it the value of validator.isURL, and provide a valid URL. Then we can log the output of this function. When we run our program, we should see the result as true. But if we test an invalid URL, say altering HTTPS, we'll receive false when we rerun the program. While it's entirely possible to implement this functionality ourselves, leveraging these well-tested, standardized solutions saves us the hassle of reinventing the wheel. While we're on the NPM module page, take note of the weekly downloads. Each package displays this metric, giving us insight into its relative popularity. For example, the validator package boasts nearly 13 million weekly downloads, which, in my opinion, is quite impressive. With such a widely used package, we're likely in good hands. Also, note the last published date. The validator package was updated just a month ago, indicating it's actively maintained. Some NPM packages might not be updated for long periods, and while they may still function, it's best to stick with actively maintained packages to avoid issues. Let's explore another example. Suppose I have a constant storing a sentence, and I want to capitalize each word in that sentence. I'll share my own simple implementation first. I split the sentence using spaces, loop through each word, capitalize the first letter, and concatenate the remainder of each word. Once I have the array of modified words, I join them together, resulting in a sentence where each word starts with a capital letter. Testing this runs as expected. While my implementation works, it might not be the most robust approach. There's always a chance I missed some edge cases or did insufficient testing. As you may know, reinventing the wheel isn't the best practice in software development. If you find yourself working on a common need, there's a good possibility someone has already created a similar solution as an NPM package. To check for such packages, Google is our best ally. For instance, if I search NPM capitalize each word, one of the top results directs us to the NPM.js site, including a specific package called Capitalize. This package, as described, is designed to capitalize the first letter of each word in a string, perfect for our needs. While this package may not have a huge number of weekly downloads, it's likely more robust and better crafted than my custom implementation. Let's go ahead and install the Capitalize package by running npm i-capitalize. Now, if we check our package.json file, we'll see that it's been added to the dependencies section, alongside the new folder in Node Modules. Next, we can replace my own implementation of capitalizing words with the functionality provided by this package. I'll comment out my version and start by requiring the Capitalize package, naming my constant capitalize. Now we can call capitalize.words, passing the original sentence as a parameter. When we log the updated sentence and run the program, we should find we get the same result as before, but now our implementation is cleaner, relying on the expertise of others. One crucial aspect of working with NPM packages is integrating them with version control systems such as Git. Let's explore that. First, we'll switch to the Source Control tab in Visual Studio Code and initialize our folder as a Git repository. Immediately, we see a staggering number of changes, 241 to be exact. This might seem unexpected, given that we've only written our app.js, package.json, and package.lock.json. But all those files in Node modules were imported and downloaded by NPM, and we shouldn't track them in source control. This is where NPM truly shines. It eliminates the need for us to manage dependencies or track changes. As NPM efficiently handles everything, we should let Git know we're not interested in tracking node modules. To do this, we'll create a .gitignore file in our project and specify the node modules folder within it. After saving our .gitignore, we'll see that we now only have 4 changes pending: the .gitignore file, app.js, packagelock.json, and package.json. This is far more manageable, allowing us to focus on the changes we truly control. Once again, everything in node modules is governed by NPM, and we shouldn't modify or track those files. With our updated .gitignore in place, we can now commit our changes. Let's provide a commit message, stage everything, and complete the commit. A related issue occurs when cloning a Node.js project. To demonstrate this, I'll quickly publish my repository to GitHub. After uploading, let's close our current project and clone the repository we just created. Once we choose a destination folder, we'll check the contents of our cloned repository. Here we find our app.js file, but upon running the program, an error arises indicating that Node cannot find the required module. The reason is clear: we're missing the node modules folder. Fortunately, our package.json file specifies all dependencies. This file is vital, particularly the dependencies section, which details every package required for the project. To retrieve all necessary packages and recreate the node modules folder, we simply run npm install. Now npm has added both packages, and we can open the node modules folder to confirm both the capitalize and validator packages are present. Thus, we should now have everything we need, and running our program should yield the expected outcome. Finally, let's take a look at the script section within package.json. Currently, we have just one script called test, which I'm not going to use. Instead, I'll replace it with a script named start. This is a special script allowing us to run our Node.js programs conveniently. To keep it straightforward, I'll specify that our script should execute node followed by the name of our main file, which in my case is app.js. With this script in place, we can conveniently run the program without manually entering the command every time. Instead of typing node app every time, we can simply run npm start, which executes the start script from package.json. When we run this script, it essentially calls node app.js behind the scenes, and we see the results of our program.